Okay, so let's do. Okay, let me just begin the first one. X3. Obviously, I'm gonna first of all follow the PEMDAS, meaning the parentheses first. So when I'm really multiplying the same variable, I'm adding the exponents. So I will have this is what I'm going to have, and obviously which will lead to right. And of course, after the parentheses, by the PEMDAS, I'm going to do the exponents, which is, and of course, because of the negative, you have to bring it down. Which is okay, so that's the answer. Okay, so I'm going to do the second one now. So the second problem is number 2. Obviously, I'm going to, of course, apply the PEMDAS, meaning I'm going to do the inside of the parentheses. Because of their negative exponents, these two will go up. Okay? So there we got, we used to have x4, y10, x negative 2, oops, over 1. Well, this is not negative, it's 2, right? So these two has to be multiplied, meaning I'm adding the exponents. Of course, the y to y. Over 1 is the same as that. And of course, we got 2. Finally, it will be okay. Okay. All right. I'm going to do number 3. Okay, so number 3. Treat it as if these are variables. So in front of this variable 3, we get 1, which is 5. Total, we got 9, radical 7. Okay, now I'm going to show you number 4. Now, in order to simplify, you have to simplify each radicals first. So here 50, I'm going to use prime factorization. So 50, I'm going to break it 5 and 10, 5 and 2. Here 32, 4, 8, 4, 2, obviously 2, 2, 2, 2. So instead of 50, I am going to write, I'm going to write it up here. Instead of 50, I'm going to write 552. Instead of 32, I'm going to write 22222. Okay? So here on the next page, I'm going to say 5 squared 2, x7, minus 2 squared 2 squared 2 x7. And I know x7 can be rewritten as x squared x squared x squared x, and of course same thing here will be 2 squared 2 squared 2 x squared x squared x squared x. Okay, and then we can really see this. There you go. Now obviously the idea as far as the simplification here is that whoever has a square, they get to come out. So 5 is coming out, x is coming out. So here we got 5x x, and remaining 2x minus here obviously we're going to have 2 xxx, which is 2 xxx 2x. So of course we're going to write it 5x cubed 2x 4x to the third power 2x. At the end we get x cubed 2x. Okay, so that's the answer. Numbers. I'm going to do number 5. Okay. 4 radical a1, 3 radical a plus 1. So you know the FOIL basically. Okay, so here will be 12a squared, as you could see, plus 4 radical a, 3 radical a plus 1. Now obviously because of the square, a has square, he's coming out 12a plus 1, 7 radical a. That's the answer. 6 will be skipped. Okay, will not be on the exam. 7 is worth. Okay, so I'm going to try 7. See, you see the small 3 here right in front of the radical sign? That's called index number. So basically that's the indicator, meaning now instead of making a group of 2, now you're going to make a group of 3. So for instance 16, you know 16 when you break it up, 2, 2, 4, 2, 2. So now here you have 2, 2, 2, 2. However, now that you're making a group of 3, well, you're going to say 2 to the third power and 2. Okay. Same thing for the x to the 5th power. Because you're making a group of 3, you're going to say x3 x squared. Now as you can see, these two are coming out. By the way, when we have odd index number, you could always pull out the negative right outside. Okay, so negative 2x squared. So that's the answer. Okay. Alright, so that's the first one. Alright, let me see. We're going to skip number 8. Okay. We're going to skip number 8. Okay, so skip number 8. let's see. Yeah, let's do number 9. 9 is important. So here, obviously, rationalizing the denominators. So here you're going to say, you could kill us about the numerator, but you're going to pick up the, obviously, that one. So therefore, you're going to get, and that's the answer. Okay. Let's do. Yeah. So I think that's good enough. Well, let's do number 10. Okay. So the 10 here is radical 3 over 5 negative radical 2. Well, here really means right. So again, you're going to use this guy. Okay. So therefore, which is in other words, this is like multiply like this. Okay. So that was number 10. Do not worry about 11 and 13. We're going to say skip. Well, might as well 12, right? So 12. Okay. I'm going to do 14 skip. I'm going to do 15. Now the 15, as you can see, x4, y8. As you can see, that we're dealing with fraction as an exponent. So not only we have to apply to x to the 4th power, y to the 8th. So here we got, let me write it big, like this. And that one get 3/4. And of course, you do this. So you're going to get x to the 3rd power, y to the 6th. And that's the answer. So it kind of looks weird, you know, the fact that we have fractions in exponent, but you know, as far as the operation is concerned, it still remains the same, meaning, you know, we will multiply, you know, and so forth, okay? Let me do 16. 16 looks very complex. So let's take a look at 16 here. Oops. Okay. So everyone's going to get, obviously, 2/3 here. So here we got 2/3, 2/3, which is, these things get canceled. So at the end, you're going to get x squared, y 2/3, right? Okay. Here is the same way. Everyone's going to get 1/2. So get canceled, so you're going to get x and y. Okay. Denominator, same way, which is x squared get 3/4, y get 3/4. So therefore, you're going to get 3/2, 3/4. Now, you could do these two first, and then you're going to subtract. So at the end, what's really happening here is 2 plus 1 minus 3 over 2, because this is considered as 1. I know I'm adding when I'm really multiplying, and I know I got to subtract. Okay? Same thing. This one, I know I'm adding because I'm multiplying the variables. When I'm dividing or canceling, you got to subtract. You just got to do this. 3, so 6, 3 over 2. This one will be 5 over 3, 12. That will be 11 over 12. And that's the answer. Okay. Yeah, let's skip 18, 19, 20, and 21, okay? 18, 19, 20, 21. Skip. That's just too much. Well, I think distance midpoint, that's too easy. So let's take a look at 22. 22 is very important in pre-cal. 22, as you could see now, this well, vertex. I don't know if you remember vertex formula, but vertex simply is negative b over 2a, comma, f negative b over 2a. Okay, so obviously in this case, a will be negative 1, b will be 0, c will be 1, right? This is a, well, we don't have x, the middle term, so it will be 0, and c will be 1. So in order to get this, which is x equals negative b over 2a, we're going to get 0, negative 0 over 2 negative 1, which is really 0. Okay? Now, obviously, forget the y value, because this turns out to be 0, which is, so y happens to be 1. So the vertex will be 0, 1. Okay? Let's go for the y-intercept now. So the y-intercept here will be, well, in order to find y-intercept, obviously what? X has got to be equal to 0. So therefore, this is it. Y equals to 1. Same thing for x-intercept. X-intercept, y's got to be 0. So then, you do this, it's going to be plus minus 1, which is 1 and negative 1. So we have 2 x-intercepts. So at the end, in order to sketch, y-intercept will be 1. X-intercept will be 1 and negative 1. Happens to be this is the vertex. These two are the y-intercept, x-intercepts. Okay. Another reason why we know this is downward is because of the negative that we have right in front. Okay, so in other words, if this one is positive, it will be like this. If that one happens to be negative, then it will be like this. So this is negative, this is positive, right? That's only for parabola equations or quadratic functions. Okay, all right. Okay. 23 is important. 23 is important. Well, let me just graph plot floor, -5. Okay, so let me start out with this one. Now, if I wanted to find or plot the point that is symmetry over x-axis, that means we're folding this paper over x-axis. So when you fold it, obviously this is where we at, which is right there, 4, 5. This is for x-axis. I should say symmetry over x-axis. If we want to find a point that is symmetry over the y-axis, so that means we're folding the paper over this line, so like this. So therefore, it has to be right there, which has got to be -4 and -5. This is again for symmetry over the y-axis. Now, origin is you do x-axis and you do y-axis. So you do it twice, with once for x-axis, another one for y-axis. So this is the point, and obviously that's for the symmetry over the origin. And that one happens to be -4 and 5. Okay? All right. So this is important. Okay? How do we run the test? It's 24. Okay. So here is a y equals to 3. Now, let's run the test for symmetry over the y-axis. Let's run this one. This really means x is gotta be -x. However, y is just the y. So in other words, what you're going to do here is you're going to change, instead of x, you're going to put -x and hope that it's going to be the same as the original function. Unfortunately, this is not the same as the original function. So therefore, you could say fail the test. Okay. Again, if we want to run the test for symmetry over the y-axis, we're changing the x value to negative. Substitute to the equation and hope that it will produce the same as the original function, which is not. Okay, let's do the other one. Now, suppose if we want to run the test for now the x-axis. Okay, so obviously then x remains the same. However, y has to be negative y. So here is the original. Now instead of y, now we're going to put negative y. I'm hoping it will be the same as the original. No, it failed. Right? So therefore,